Hello, my dear students. This is Ellen Brand of Chemistry. My name is B. Lakshminarayana. So, today we are going to discuss the classification of elements. Last two topics: electron gain enthalpy, electronegativity, then diagonal relationship, and as well as nature of oxides that we have to discuss. Last topic in the classification of elements. So, once again, I'm telling to you, this is Ellen Brand of Chemistry. Then my name is B. Lakshminarayana. So then every day, morning and evening, one live session will come. So better to subscribe my channel, take updates from the chemistry. Then whatever the topics we are covered in the EAPCET and as well as JEE Mains examination, all the topics will cover. So in these 45 days, so from the today onwards, be focused on your goal. Then now we have to discuss about electron gain enthalpy. Electron gain enthalpy. So what is the electron gain enthalpy? Enthalpy change, nothing but energy change. Enthalpy change in the addition of electron to neutral gaseous atom. Enthalpy change in the addition of electron to neutral gaseous atom is called as electron gain enthalpy. The enthalpy change in addition of electron to neutral gaseous atom is called electron gain enthalpy. So this is energy change. So here the energy change that it may be releases or may be absorbs. So when absorption takes place, the attraction forces are greater. Attraction forces are greater than the repulsion forces. Attraction forces are greater than the repulsion forces. At that time, energy release energy. Remember? So when the attraction forces are greater than the repulsion forces, energy releases. In case reverse, then repulsion forces are greater than the attraction forces. At that time, energy will be absorbed. Absorb energy. So this is electron gain enthalpy. Actually, electron affinity will be there. No? Electron affinity, nothing but it is the tendency of an atom. It is the tendency of an atom when electron is added to. It is the tendency of atom attract electrons. It is the tendency of an atom attract electron when electron is added to neutral gaseous atom. Remember, it is the tendency, the capacity attract electron when it is added to neutral gaseous atom. So this tendency generally measured in the electron gain enthalpy. So remember, it's very important. Electron affinity is measured in electron gain enthalpy. Lo measure cheyoచ్చు. Yes, noted this. So I told that so electron affinity is measured in electron gain enthalpy. Electron affinity is measured in electron gain enthalpy. Sir, here remember, more negative electron gain enthalpy, more electron gain enthalpy is present, that we call it is a more electron affinity. Less negative electron gain enthalpy, that is equals to less electron affinity. సో ఎలక్ట్రాన్ అఫినిటీని దేనిలో మెజర్ చేస్తాం? ఎలక్ట్రాన్ గెయిన్ ఎంథాల్పీలో మెజర్ చేస్తాం. ఎలక్ట్రాన్ గెయిన్ ఎంథాల్పీ మోర్ ఉంటే ఎలక్ట్రాన్ అఫినిటీ మోర్ ఉన్నట్టు, ఎలక్ట్రాన్ గెయిన్ ఎంథాల్పీ లెస్ ఉంటే ఎలక్ట్రాన్ అఫినిటీ లెస్ ఉన్నట్టు. సో దట్ ఈస్ ఎలక్ట్రాన్ అఫినిటీ. సో క్లియర్? నౌ ఫ్యాక్టర్స్ ఎఫెక్టింగ్ ఎలక్ట్రాన్ గెయిన్ ఎంథాల్పీ. Factors affecting electron gain enthalpy. Factors affecting electron gain enthalpy. Sir, even in this also, first one, that is ZFF, that we call what? Effective atomic number, effective nuclear charge, what we call effective nuclear charge. So effective nuclear charge ki ela untundi? Effective nuclear charge is greater, then electron affinity is also greater, or directly proportional. So electron affinity is directly proportional to ZEFF. Sir, ZEFF, then effective nuclear charge is greater, then electron affinity is greater. Sir, one of the example for this, then fluorine and oxygen if you take. So fluorine and oxygen if you take. Sir, oxygen, fluorine, effective nuclear charge we are already discussed. Sir, here the effective nuclear charge you can get it is effective nuclear charge is equals to then Z minus sigma. So Z atomic number for oxygen is 8, then minus, sir, what is the oxygen electronic configuration? 1s2, 2s2, 2p4, 8. So now these are the outermost electrons, these are the core electrons. So sigma nothing but what? Core electrons. Then how much you can get? 6 you can get. So for this Z effective you can get it is 7, right? For this 6, for this 7. Sir, effective nuclear charge which is having greater, that is electron affinity is greater. So oxygen fluorine compare cheste, fluorine ki electron affinity ఎక్కువ. Clear? Then next we will discuss the second factor. Second factor that is atomic radius. Atomic radius increases, electron affinity decreases, inversely proportional. Atomic radius increases, electron affinity decreases. The second one, atomic size. Electron affinity is inversely proportional to atomic size. So electron affinity, atomic size inversely proportional. In case any group if you take, so group elements if you take, for example, lithium, sodium, potassium, rubidium, then cesium if you take. From the top to bottom, what happens? Atomic size what happens? Increases. Atomic size increases. Note it. ఇలా సింబలేషన్ అంటే ఇంక్రీజ్. సో అటామిక్ సైజ్ ఇంక్రీజ్ అవుతా ఉంటే టాప్ టు బాటమ్ ఎఫెక్టివ్ electron affinity, what happens? Electron affinity decreases. Electron affinity decreases. This is a second factor. Third one. So what is the third factor? So we know half-filled and full-filled electronic configuration. So half-filled and full-filled electronic configurations. Electronic configurations if you observe. Half-filled and full-filled electronic configurations if you observe. So half-filled, full-filled electronic configurations if you take, so that both are the stable electronic configurations I told. The stable electronic configurations. Stable electronic configurations. So stable electronic configurations of electron affinity is greater when comparative to unstable electronic configurations. So stable electronic configurations are greater electron affinity. So electron affinity of elements which has stable electronic configuration, that is more than elements which are having unstable electronic configuration. So that is the third factor. Next, fourth factor if you take, penetration effect. So what is the penetration effect, you know? So penetration effect is nothing but, sir, here which are very near to the nucleus, which are electrons attract more towards the nucleus, that we call penetration effect. Then here the penetration effect in the s orbital is greater than that of p orbital, than that of d orbital, than that of f orbital. So look at the addition of electron to the s orbital is more attract towards the nucleus. So electron affinity greater. Sir, in case electron is added to s subcell when comparative to p subcell, that you have to remember. Electron affinity is more if electron is added to s subcell when compared to p subcell. So these are the factors which are influence the electron affinity. So all the factors are noted. Then we'll discuss most important points in the electron affinity. Yes, so look at some important points in the electron gain enthalpy. The first important point, that is, you have to remember, for all neutral atoms, electron gain enthalpy, so better to take delta H easy. Electron gain enthalpy. Remember, electron gain enthalpy, that is equals to negative for all atoms. Negative. Clear? Then, for example, in case of oxygen neutral atom, carbon neutral atom is there. if we add electron, then we can get O minus ion ostundi. Then if we add one electron for this, then carbon minus you can get. The electron gain enthalpy you can get negative. Electron gain enthalpy that you can get, it is negative. Electron gain enthalpy negative. For all neutral atoms, electron gain enthalpy is negative. But the exception case, but some elements such as beryllium, which are beryllium, magnesium, nitrogen, and noble gases such as helium, neon, argon, krypton, xenon, all this. So some elements, beryllium, magnesium, nitrogen, noble gases, helium. So this is even neutral electron gain enthalpy positive for these elements. Remember, positive, వీటికి positives. For example, beryllium తీసుకున్నాను. Beryllium, if you add one electron, then you can get Be minus. For this delta H electron gain enthalpy, you can get positive. For all the neutral atom, negative. For these special elements, beryllium, magnesium, noble gases, you can get positive. Next, for cations అయితే delta H is electron gain enthalpy, you can get negative again. Negative for what? Cations. In case for anions, delta H is electron gain enthalpy, can get positive. So then one more very important point, that is, so first electron gain enthalpy, it may be positive or negative. Remember, first electron gain enthalpy, delta H1 is E, first electron gain enthalpy. Sorry, it may be positive or negative. First electron gain enthalpy, it may be positive or negative. But second electron gain enthalpy, that means second electron add చేసినప్పుడు second electron gain enthalpy, it is always positive. Second electron gain enthalpy always positive. So these are the most important points in the electron gain enthalpy. So we'll see some of the questions if you note it. So note all these, then we'll discuss some important previous year